So we have a question to solve. The A part is saying that we should prove that when we differentiate this, we get that. Right. Then the B part says we should use our result from part A to evaluate the area of the shaded region. Okay, so that is this part. Well, let's start with the A. We should prove. So let's prove. Now, A says we should prove that when we differentiate x e to the power x minus e to the power x, we will get x e to the power x, right? Okay, so let's prove that. Let's use this pen. Okay, so let's prove it. Now, know that what we have here is product. So we are going to use the knowledge of product rule on this. So we would differentiate x and then maintain e to the power x. But when you differentiate x, you get 1. Okay, so that's your answer. Plus, we will now maintain e to the, we will now maintain x and differentiate e to the power x. And when you differentiate e to the power x, your answer is still e to the power x. Minus, then we differentiate e to the power x. Now, this last bit of e to the power x too, when you differentiate, you should get e to the power x. All right, now what can we see? Well, if you consider this should cancel out that. Okay, so we can simplify to say that indeed our answer is x e to the power x. Now we are supposed to find the area of the curve, okay, the area under the curve. That is what we are supposed to find. Fine, let us copy this curve. Okay, let us copy this curve and then bring it here. Okay, so we have the curve here. Yeah, big enough. All right. Now the question said that from part A, okay, from part A, we should be able to evaluate. But what did we get from part A? That will help us to find this shaded area. Now, ideally, if we are supposed to integrate and then find the area over there, what you would have done is to write the integral from 0 to 2 of x e x dx. This is what you would want to integrate. But what would you give you? That is the problem. So the question says we should go to A. Now, whenever you are solving a question that says that refer to part A, please do so because there's a clue there. Now, from part A, we realize that the differential of x minus e to the power x gives us what we have here. Right. Now, what this means is that should we differentiate what is here, we get this. Now, the reverse is also true. That is, should we integrate what is here, this is what we should get. So that is exactly what we would do. We will integrate both sides, okay? Now, when that happens, this side, the left-hand side, gives us x ex minus ex. So if you compare to what we are supposed to do, then you would say that, yeah, we are getting there. Because this is exactly what we have here. All right? So, well, I want to rewrite it this way. I like to write from the left to the right, so I'll write it this way. Okay. Now, the question says we should integrate from 0 to 2, right? So now what this means is that if we are integrating from 0 to 2, and this is what we have as a result of integration, then we must deal with the boundaries as well. So what we do is to input 2 into where we find x, then minus, we input 0 into where we find x, and then we are done. So let's do that. Now, using 2, we have 2e2 minus e squared, okay? Then using 0, we have 0e0 minus e0. Now, be careful. E to the power 0 is 1, okay? So not everything within this bracket will be 0. All right. So this will give us e to the power 2 minus. Now, this should give us 0 because 0 times anything is 0, but e to the power 0 is 1, and that will be negative 1. Okay, but negative 1 times this negative will be positive 1. All right, so plus 1. Now, since it was an area that we are looking for, okay, our unit is very important. Okay, so we just end by saying unit square, and then we are done.